Hello, boys and girls. Today we are going to be talking about shapes of distribution. This is 27-3 in your notebook. Please make sure that you have it labeled. Don't forget to put your page number in the top and add it to your table of contents. For shapes of distribution, we are going to be talking about graphing data. So when you graph data, for example, the number of pets the students in our class have, when you're graphing that data, you're going to notice that it forms a shape. One of the shapes it will form is symmetrical. Symmetrical. Now, symmetrical is when two halves are the same. So it's kind of bell-shaped. And I drew a cute illustration there of a bell. Hope you appreciate that. I'm going to show you what this would look like. So let's say we've got some data. And our data has primarily clumped in the middle. So we don't really know what this data represents. We're just showing an example of what symmetrical data would look like. So we've got 1, 2, 3, 4, 5, 6 data points there. And to the right of that, there would be fewer. And to the right of that, there would be fewer, and so forth and so on. So it would curve down in this way. To the left of the center, the data would also be less. So let's say this represents the number of pets students in our class have. So we've got this symmetrical data where more students have this middle range and fewer students have pets looking out to the sides. If you drew a line kind of loosely around the data points, it would look like a mountain or a bell shaped, and so basically you have two halves occurring. One half here, one half here. They are about the same. We call them symmetrical. So we say the distribution of the data is symmetrical. Okay. Now, another way to describe the data that I want to talk to you about is skewedness. Okay, so skewed. Skewed is when one side is longer than the other. One side is longer than the other. A distribution can be skewed either to the right or to the left. So let's look at an example here. And let's say in this data, we have primarily a big group of data over here on the right-hand side with a few pieces over to the left. So it might look something like this, where we've got a lot of data over here, and then maybe only one over here. Maybe there's an outlier heading out this way. So this would indicate that most students in our class had more pets. And if we draw a line loosely around the points, we find that there's this tail heading over to the left. And we call that skewed left. So you can go ahead and copy that down. Skewed left. So I'm sure you can guess what skewed right means. Skewed right means that the data is primarily on this side of the graph, and it decreases as you go to the right, and there might even be outliers over here on this side. So the skewedness of this data, or this distribution of data, is skewed to the right because the tail is at the right. It's all about the tail. Tail's on the right, it's skewed right. Tail's on the left, skewed left. That is how you would describe the distribution. I'd say this distribution is skewed left. This distribution of data is skewed right. And that just means that more students have fewer number of pets than more pets. Fewer students have greater number of pets. So that's skewedness, another way that you can describe the shape of the data. Which brings me, the tail determines skewedness. It's all about the tail. The last kind I want to talk about is uniform. So uniform distribution is when the distribution of the values occur pretty much evenly, the same number of times throughout. So for our graph, our uniform distribution might look like, if we're talking about the number of students who have pets, or the number of pets the students in our class have, let's say our data ends up becoming where we've got kind of like this mix. So you really can't discern any type of a pattern. Okay, it's very mixed. We would call this uniform because the distribution seems to occur evenly. There doesn't seem to be any skewedness. It's not the same as when you have symmetrical, when you have the bell curve, when you have the bigger chunk in the middle and the two ends have less data. This is when the data is spread out amongst all the values. This would be a uniform distribution. So just to review, we use the graph data and we notice that it forms a shape. That shape could be symmetrical. It could be skewed, either to the left, where the tail is, or to the right. Or it could be a more uniform distribution and spread very evenly across the values. Now with this information, you are able to complete today's worksheet or lesson in class. It's going to be on page 357. And 357 starts out with us listing the results from the class survey for the number of pets for the students in your class. Since I can't be here with you in class today, I'm going to give you the results of the survey for the number of pets for the students in our class. So you're going to need to write down this data. 0, 0, 3, 0, 0, 5, 0, 1, 0, 0, 0, 1, 1, 0, 8, 5, 0, 0, 0, 0, 0, 3, 0, 0, 3, 0, 7, 0. So this looks like not everybody in our class has answered the survey, so we do not have 32 pieces of data here, but that's okay. We'll do with what we've got. So that is the data from the class survey. What you're going to need to do is determine whether a bar chart, or a dot plot is appropriate to the graph, or appropriate to graph the distribution for the number of pets for the students in our class. So how many of you think it's a bar chart? Remember, bar charts look like this. How many of you think it should be a dot plot? Dot plots look like this. If you said dot plot, give yourself a thumbs up. A dot plot would be appropriate. So you'll need to draw a line, and then you'll need to graph the distribution for the number of pets for the students. So we have a range here. You'll want to set up your range on your dot plot from 0 to 7. Actually to 8, because you have 8 for one of your data points. And then you're just going to go ahead and graph them. So 0, what I always recommend doing is crossing them out lightly as you go. 0. Make sure that you are evenly spacing. You'll need to be consistent across all of the values or it won't look right. 3, 0. We're going to have a lot of zeros. It's going to go up high. 0, 5, 0, still about evenly spaced. 1, 0, 0, 0, 1, 1. And see how they're still evenly spaced roughly across from each other? Another 0, 8, 5, about evenly spaced, 0, so forth and so on. You can continue to add these points to your dot plot and then continue on answering 3 and 4, describing the shape of the distribution, how it's different from its height, so how high versus the shape of it, and then whether or not you see any unusual values in the data for the number of pets and why you would think it would be unusual. You can work on those with your math teams. Continue through 358, working through all of these questions with your teams. When you get to page 559, you will recognize this information from our notes. You can review that and then continue on with this scenario here with Lorelei and her phone book. All right. When you are done with that, your homework for tonight, actually, we're not at the homework yet. You still need to continue on through 12, 13, 14, 15, and 16. And then you'll get to the homework, which is going to be check your understanding and lesson 27.3 practice on page 361. I know this is a long video. Please feel free to replay it so that you can copy your notes. If you didn't get all the notes the first time around, it is important for you to have your own copy. And I look forward to seeing you on Tuesday. Have a wonderful day.